Hi, this is Alan Wu. Today we are going to talk about hidden Markov model for MIDI file, a new prototype in Kyma. In this video, we are going to first talk about the concept of Markov model, and then we can go to Kyma and see how Markov model is applied and hidden. A Markov model is a chance operation that takes the previous event into consideration. An event, in the case of music, can be referred to notes, rhythm, sound, amplitude, positions, and other music elements. Take an example of this piece. If we take a statistic approach of every pitches in the happy birthday and see how many chances each note can go to other note. Like the middle C here, it goes to itself 1, 2, and 3 times. And also the middle C can go to D 1, 2 times. And then we see the middle C goes to F 1 time, and it goes to G 1 time, and it goes to higher octave C 1 time. After normalizing the statistics, we can see the note middle C can be followed by middle C by 37.5% of chances in this piece, and C is followed by D by 25% of chance in this piece, and 12.5% of chances the C can follow by F, G, and higher octave C. So this Markov matrix down here is a chart of every note in the row followed by every note in the column. So for example, there's 100% of chances A is definitely followed by the F, and also the high C, 100% chance is going to follow by A. This is a way for computer to learn and decide which note can be followed after the previous one and somehow maintain the style of the music. Now let's get into Kyma. I have my happy birthday.midi over here. Now we can go to hidden Markov model pattern generator on MIDI files. I have one already done here. That puts the happy birthday.midi file into the MIDI file name, and I set up channel 1 to analyze. Also, for the sake of fun, I click on show image display to show the self-similarity matrix, and let's hit play. Over here you can see I set up maintain pitch to 1, maintain position, and maintain time to next to 0. That means for now only pitch is relevant in the Markov model, exactly like the Markov matrix we did here. Let's listen to it. You can hear the music generated by the Markov model is following this random pattern. For example, you can hear the C followed by C more than the other note, and the G is always followed by the F, and A is always followed by the F too. In the self-similarity matrix, the x-axis on the top represents the piece from start to the end, and also the right axis on the left from top to bottom represent the piece from the. Therefore, the downward diagonal is always similar to itself because it is the same place in the piece. Also, in the matrix, the same color represents the same event. Therefore, you can see the C over here in the beginning of the piece equal to the other C over here, and with the same color, this is B flat next to each other. Self-similarity matrix is a popular approach of machine listening to music forms. For example, if you see a symmetrical pattern alongside the downward diagonal line, it represents a pattern of repetition in the piece. Take Happy Birthday for example. You can see very clearly this piece start from around the note with C in the brown color and gradually moving toward the note F with the green color. Now let's try putting rhythms instead of pitches into the Markov chain. To do that, let's put the maintain pitch to 0 and maintain time to the next to 1. Now the Markov model only takes rhythm as consideration. Let's listen to it. You can not only see the self-similarity matrix is different, but also you can hear the generated music tends to maintain the rhythmic pattern instead of pitches. We can also put two of them together. So now you can hear this is a lot similar to the original piece. You can also choose to maintain the position of notes in a hyperbar. A hyperbar can be considered as phrase or subphrases in music. In this piece is 3/4 time, with subphrases of 2 bars. Therefore, in the hidden Markov model pattern generator on MIDI file, we can set up hyperbar to 6 beats. Now let's hear how the maintain position works for itself. You can hear it maintains the overall structure of the piece very well. Now, after knowing how the Markov model works, let's talk about what is hidden Markov model. A hidden Markov model is to add another layer of chance operations on top of Markov models. This allows the computer to play quote-unquote wrong note once in a while. For example, we can set up the maintain pitch to 0.5. That means only 50% of time the Kyma is going to play according to the Markov model, and in another 50% of time, Kyma will just play a random pitch. Now you can freely adjust the percentage of how much the Kyma will follow the rhythm, pitch, and positions to play your piece. And this is the introduction of hidden Markov pattern generator on MIDI files in Kyma system. In next video, we will look into some examples and see how to use HMM pattern generator on MIDI files to generate more impressive music. Until then, keep having fun. See you next time.